Process cabinet assembly is a workflow scenario designed to demonstrate the steps involved in processing a SolidWorks CAD model assembly and prepare information for manufacturing and the shop floor. This step illustrates the automated processing of SolidWorks CAD model assemblies to help automate the product engineering process.
Automated assembly processing starts with launching SolidWorks and selecting a sheet metal cabinet model assembly. This is followed by selecting the Tools, Global Edge, Export Files option, which will display the following file export screen and menu options. Check the sheet metal option followed by the filter option to filter out the sheet metal parts contained in the assembly. At this point, you can either select the Select All option or choose individual files to process.
This step illustrates the automated sheet metal batch unfolding capabilities, including the incorporation of extended data into DXF flat files to facilitate automated CAM program generation.
At the lower portion of the file export screen, there are checkboxes to select the following export options. These options include the ability to perform an importation of complete CAD part parameters, which serve as a foundation for manufacturability testing, automated routing generation, and automated BEN program generation. This includes the automated incorporation of extended data into the DXF flat files that can be directly imported into CAM bending software. This process eliminates the manual programming of sheet metal part files for press brakes, robotic folders, and panel benders. Select the Export button to start the processing of the selected sheet metal part with the output options that were selected below.
This step illustrates the automated CAD part analysis capabilities to provide CAD part parameters for automated routing generation, manufacturability testing, quoting, and CAM program generation.
As the sheet metal is processed with automated CAD part analysis functionality, the part is fully analyzed, and complete CAD part parameters are inserted into the Global Edge database. The software then utilizes these CAD part parameters to perform a manufacturability test, which compares these parameters with matching shop floor machine tools. This process provides design for manufacturing functionality that identifies potential fabrication errors at the design stage to help ensure sheet metal parts can be successfully fabricated before reaching the shop floor. The automated CAD part analysis process culminates with the automated generation of optimal routing steps based on the CAD part parameters and matching machine tool capabilities. This includes the generation of DXF flat files that incorporate the necessary extended data to facilitate CAM BEN program generation.
This step illustrates the automated routing generation capabilities to generate optimal routing steps based on CAD part parameters.
Select the Routing button to display the routing steps that were generated during the processing of the sheet metal part. Select the Close button to return to the import screen, and select the Test Results button to access the results of the manufacturability test that was performed during the processing of the sheet metal part.
This step illustrates the automated manufacturability testing capabilities to identify potential sheet metal fabrication errors before parts leave engineering.
The Test Part tab displays the individual tests that were performed on the selected sheet metal part. The CAD Value column displays each of the CAD part parameters that are contained in the sheet metal CAD model. The Test Limit column displays the test limit values that are defined in the matching BEN process. The Status column displays whether the CAD part parameter value falls within the BEN process limit by indicating either Pass, Fail, or Warning, which indicates it could be a potential issue. The DXF Image tab displays an image of the DXF flat file. This screen provides the ability to scroll Next and Previous through each of the CAD part test parameters and the test results. When selecting the Manufacturability Test option in the lower right-hand corner of the screen, the DXF flat file image will highlight an error in red. In our example, the following PEM holes appear in red because they were identified as being too close to a bend line. The Dimensions, Parameters tab provides a complete listing of each of the imported CAD part parameters. These CAD part parameters provide the foundation throughout the Global Edge system for automated CAM BEN program generation, automated routing generation, automated production job generation, and automated sales quote generation.
This step illustrates the generation of a complete manufacturing bill of materials based on CAD part parameters and the automated generation of optimal routing steps including tooling.
As the cabinet assembly was processed with the Global Edge software, a complete manufacturing bill of materials was generated, which includes routing steps for each component. Select the BOM option to display the following screen form and menu options. Select the level option and enter 3 followed by OK. Select the view option to scroll through the bill of materials. Select Cancel followed by Quit. To return to the main part menu, select Find followed by BOM option to navigate one level down the bill of materials structure of the cabinet assembly. Repeat this process one more time to navigate one more level down the bill of materials structure to arrive at the component level. Select BOM followed by the Routings option to display the routing steps that were generated for the displayed cabinet assembly component. Each routing step includes the setup and process cost, including the matching machine tool.
To schedule a demonstration and learn how the Global Edge Engineering Assistant can help your company increase engineering capacity and save thousands of hours, please visit www.ldcglobal.com.